Students, this is the circle problem video for the Unit 6 study guide. Taking a look at the study guide, you need to very carefully read these 2 pages. These are the things you must have memorized for this test. So this page is filled out, and then your first 2 pages of your test will basically look like this. Blank, you fill it out. It's going to be about 10% of your test itself. Let's work on those circled problems. So number 3 says use the point-slope equation of a line, y minus y1 equals slope x minus x1, to write 2 equations of a line with a given description. Your final equation should be in y equals mx plus b form. So we have given equations, and then we have a mystery line with a given description. Our given line is y equals 9x minus 5. So for A, it says find the equation of a line that is parallel to this line and passes through the point. Let's find the equation of a line that is perpendicular and passes through this point. The entire key to this problem is to remember what is the relationship of slope and parallel and perpendicular lines. For parallel, we know that the slopes are equal. Write this down. And for perpendicular, we know it's slope times slope equals -1. So I'm going to go ahead and get you started on the B, and you need to finish A. So the work for B is going to be over here. Follow the example and you do the work for A. So we have the given line, which is y equals 9x minus 5. That's the given line. And we want the slope to be times -1. So 9 times something equals -1. And we have to ask ourselves, what is that something for it to be perpendicular? And the something is the opposite reciprocal, so -1/9. Now we take our point-slope equation of a line, which is y minus y1 equals slope x minus x1. That's your template. You always make a template first. So write that template out. Now you circle plug chug. That's y1 there. So here's y1. That's going to plug in right there. 2. Your slope, plug-ins right where the slope belongs, which is -1/9. And then your x1 is right here, -6. I'm going to watch those double negatives. We see we have double negative here. That's going to become positive. Now we're going to distribute that -1/9. You could either distribute, or if you want to get rid of it, one way you can get rid of it is simply multiply everything by 9. That might actually be faster. So we're going to go like this. When you do this, if you choose to do it this way, make sure you distribute it to the far side as well. In fact, let me put the 9 over there so you don't forget. So this 9 here, and we're going to go like this. So here, here, and here. And to cancel that negative, we're going to make this a -9. So watch carefully. That's going to be -9y plus 18 equals, that -9 cancels that -1/9, so that's +1 now. So now this is left untouched. Now you want to solve for the slope. Or excuse me, solve for y. Get it into y equals mx plus b. So we're going to go -18 I'm going to bring my work over here. So we have negative 9y equals x, and we have 6 minus 18. So that's going to be negative 12. And now we divide by negative 9. So our final equation is y equals negative 1 over 9x plus 9 goes in there once. Double negative makes that positive. We have 3 left over, so that's going to be 3 over 9, which is 1/3. Don't be intimidated by that mixed number. That is the actual answer. Now don't forget, you still have A to finish up here. There's an A and a B. We just did B. It says draw a diagram, show your work. It says the length of a rectangle is 4 times its width. The perimeter of the rectangle is 90 feet. Find its area. So very slowly, let's put in our information. Length, put an L there, of a rectangle is, that's an equal sign, 4 times its width. Learn to put stuff right by the words. And we're told here, the perimeter of the rectangle is 90 feet. We want to find the area. Area equals length times width. So as you read these kind of more complex word problems, underline, bring out the equations very carefully. Now we're going to draw, label, list, cross out. We have a rectangle, so I draw a rectangle. I put in my given information. The length is 4 times the width. That would make this the width. That's 4 width. Okay? Taking care of this information. Notice I'm crossing it out as I deal with it. The perimeter is, so I write P equals 90 feet. Right underneath it, I'm going to write out the equation for perimeter, which is simply walking it around. If you put your pen here and you walk it around, it's 2 lengths plus 2 widths. And then the area equation we have here, area equals length times width. Now we circle, plug, chug. We have perimeter, it's 90. So we can put 90 here, equals 2. And then our lengths can be replaced with this 4W. That way we're down to 1 variable. Plus 2W. If you look carefully, you can also just count it up. W plus 4W is 5W. Plus W plus 4W. That ultimately is 10. So you solve for W, solve for both the width, and then solve for the length, and then you will get the area. You finish the work there. It says take the given information below, mark it on the rectangle, then find all possible segment and side lengths. Okay, let's be very careful with this. We know EI is 4x plus 5. That's EI, that's orange. That's going to be 4x plus 5. And we're told GI is 5x plus 1. Now what we know, and then we have IGH. Very important that you follow exactly this letter. The way I think of it is, think of this as a head, shoulder, elbow, wrist. The shoulder is going to be I, G is the elbow, and the wrist is H. I, G, H. Learn to trace dot to dot. That seems simplistic, but I still have several of you that aren't getting these angles in the right place. Very, very carefully. Shoulder, elbow, wrist. So we go I, G, H. We stop at H. Our elbow is right there at G. That's where the 51 belongs. Okay. Now, ask yourself, what do we know about rectangles? Several things. One, we know the diagonals bisect and they're in equal length. So all four of these pieces are equal. That means we can do this. We can say EI is equal to GI. From there you can circle, plug, chug, and you solve for those sides. We also know this, that the opposite sides are equal, of course. And if you look carefully, we have an isosceles triangle here. And if we have two equal sides, we have two equal angles. So we have the 51 here. Keep in mind the corners are 90. So you should be able to easily find that squiggle angle. And because, again, of an isosceles triangle, you can find the squiggle angle here. And then using armpits of the Z, you can get these. So all of these angles you can easily walk yourself around. You find X. After you find X, you want to find the length of this side. I'm going to bring that over here. So you're going to find the yellow. And then after you find the yellow, you then want to work on getting the outer sides. Don't forget this, the hot pink one and the light pink. So get the yellow first, and you're going to get the hot pink and the light pink using SOHCAHTOA. This is the opposite. This would be the adjacent, and once you have the yellow, you'll have the hypo. So for the hot pink, you're going to have the hypo once you find X and plug it in. And you're going to need the opposite. That's an OH combo, so you're going to use sine of theta over 1 equals opposite over hypo. That's for the hot pink. And for the light pink, you're going to have, again, the hypo. But you're going to need, this time, the adjacent. And it's an AH combo, so that's ka, like a crow. Cosine theta over 1 equals adjacent over hypo. So in order to get these on the outside, you have to use SOHCAHTOA. Okay, so for 1011, it says you've been given a rhombus. With the given information, find all possible angle measures and segment and side lengths. Show your work. So before we do anything else, let's mark everything we know about a rhombus. This is why you have to memorize this first page here. We have to know what we know about a rhombus. So let's go through this list. A rhombus is a parallelogram, so it has all the OCD qualities plus 4 congruent sides. Plus diagonals which are perpendicular and make a right angle in that middle there. And finally, diagonals that bisect the corner angles. So these angles are going to be cut in half by these diagonals. Okay, keeping that all in mind, that's why you have to memorize this page. Let's go back to that problem. So let's first mark everything we do know. Since it is a rhombus, let's get what we know straight. We know all four sides are equal. We know these corners are going to be bisected. We also know these diagonals bisect those corners, but they're also perpendicular. Because it's a parallelogram, these sides are parallel, of course. So once you know all that, let's see what we can do here. We are told that EG is 16. So EG, that whole thing is 16 instantly. Since you know that this is a midpoint, let's break it up. That's going to be 8 and 8. Just get in the habit of automatically bisecting that. We're told that FG is 17. F to G is 17. And we're told that the measure of DFG is 28. D, again, DFG. Think of this as head, shoulder, elbow, wrist. Okay, so D would be the shoulder. F is going to be the elbow. Wrist, right there. So follow that very carefully. Don't get that in the wrong place. That's D, F, G. Stop at the elbow sweep. That, ladies and gentlemen, is 28 degrees. So you ask yourself, what can you now find? Well, just walk yourself around the obvious. We just said the corners get bisected, so you can carry this 28 over here. And because it does have the OCD qualities, this third O is opposite sides are congruent. Now there's several other things you should be able to find. Let me highlight them for you in yellow. Obviously all of those. These angles here. Most importantly, don't forget this diagonal as well. And you can see how to do that. If you have a right angle, let's do your right triangle toolbox. Your right triangle toolbox. Let's see. If we wanted to know this, let's call it X. We can use leg squared plus leg squared equals hypo squared. 30, 60, 90. 45, 45, 90. SOHCAHTOA. And inverse SOHCAHTOA. So that's your right triangle toolbox. These are things you can use when you see a right triangle. You should have this memorized. So let's see things we could or couldn't use here. So to get X, we have two sides and we need a third side. So we could use Pythagorean Theorem. We can't use 30, 60, 90 or 45, 45, 90 because that's not the angles we have going on here. We do, however, we have an angle and we have a side length. We could use SOHCAHTOA, so SOHCAHTOA would work. We're not going to use inverse SOHCAHTOA because we're not looking for angles. We already have them all. So in this case, you could actually use two things, Pythagorean Theorem or SOHCAHTOA. You find the rest that I've highlighted. It says underline the keywords and solve. It says the sum of the interior angles measures of a convex polygon is 1080. How many sides does it have? Really important. You get used to underlining keywords. These two problems go back to this song that you should have memorized. It goes right here. I dare you to sing it with me right now. It's going to help you if you try. Okay. The sum of interior angles, sides minus 2 times 180. The sum of exterior angles will always be 360. Each angle of a regular polygon, sum over sides, ain't this fun? The sum of interior angles, sides minus 2 times 180. Knowing that, let's go back and see what we can do here. So it says the sum of the interior angles. So we're going to write it down. The sum of interior angles, sides minus 2 times 180 equals sum interior angles. Remember, equations have two sides with an equal sign. That's really important. You always put both sides with an equal sign. Says it's a polygon. That's a hint. You don't know the n. Is 1080. Remember, that is an equal sign. That's this equal sign right here. So we're going to plug 1080 here. And we have n minus 2 times 180. We're being asked how many sides does it have. So again, we're looking for n here. You're going to do your own algebra. Your job is to find n. So notice what I did here. I read it out loud. I underlined keywords. I figured out which equation to use. Equations have two sides with an equal sign. And then we're going to go to do circle, plug, chug, and solve. It says for 16 and 17, find the missing coordinates to make a parallelogram. Now, parallelogram, remember, means opposite sides have to be parallel. So for 16, first you want to find you want to make those parallel. So we're going to find the slope first of the blue. Slope equals y minus y over x minus x. Slope equals, we make a template, and now we're going to plug our numbers in. That's 7, negative 6, negative 3, and negative 1. Double negative makes a positive, so I have 13 over double negative makes a positive, and I mean negative 2. So 13 over negative 2 is my slope here. Now remember, this is rise over run. So whatever I want here, whatever my x and y coordinate, it has to create a slope of 13 over 2. So let's do this one step at a time. I'm going to work with the rises first. We know our rise has to equal 13. So we go like this. Y minus negative 8 is 13. The run is going to be negative 2. So whatever the run is, x minus 6 has to be negative 2. Now we're going to solve. Double negative makes a positive. So I have y plus 8 equals 13. I'm going to minus 8 both sides. And I end up with my y coordinate equaling 5. And then for here, we're going to add 6 both sides. and I have x equals 4. Now, what's really nice is it's super easy to check these. Once you use the one set of sides, now we're going to go this way and check going this way, because these have to be parallel too. So now using those coordinates, let's check our y minus y over x minus x and make sure they're the same. So we're going to go 7 minus 5, that's 2, over negative 3 minus 4. It's going to be negative 7. Let's try this. Negative 6 minus negative 8. There's a double negative there, so that's positive 2. And negative 1 minus negative 8. Hear that double negative? That makes that going to be negative 7. And you see it works. So your coordinates are 4, 5. It says darken the corner of the triangle and label the given coordinates. Rotate 90 degrees counterclockwise. Show both the new coordinates on the left and draw the second triangle. So we're going to do 90 degrees counterclockwise. If you go to the front, take a look here, you must have these memorized. So our rotation is to rotate 90 clockwise, we switch and flip to the right. To rotate 90 counterclockwise, switch and flip to the left. So we're going to switch and flip the sign going counterclockwise, which is to the left. So let's first get our coordinates. Doesn't matter what letters or coordinates you use. I'm just going to use PQR. So we have P, and our P coordinate is negative 5, positive 3, our Q coordinate is negative 3, positive 4. And our R coordinate is going to be negative 2, positive 1. And our job is to rotate this 90 degrees, all 3 coordinates. I'm going to do the first one. You do the next 2. So we switch and then we flip to the left. So first we switch the order. So it's 3, negative 5. So write them just like to switch the orders. Now I'm going to draw a counterclockwise arrow and flip the sign. So my coordinate there is negative 3, negative 5. That's sub P. So negative 3, negative 5. This is where your sub P is going to be. So switch and flip to the left, the other coordinates, draw your triangle in, and it should look like it's rotating 90 degrees counterclockwise. Okay, it says darken the original endpoints, then dilate the shape according to the directions. Draw the resulting image. Dilate. Now dilate, we go back in here to this. How do we change things? Motion on a coordinate plane. Dilation, it says to change in size, just multiply. To change in size, we multiply. So we're going to darken those endpoints. So we have one endpoint here, and it is at positive 5 and positive 10. We'll call that A. And we're going to want a sub A. And then here we have B, and B is at 10 and 5. And A is at 5 and 10. Let me get my color straight here. So to change in size, we multiply. So we're going to do a scale factor of 3/5. So we take 5, and we're going to times by 3 over 5. Then we're going to take 10 and times by 3 over 5 as well. So for each of these, we simply times by 3 over 5. So I'm going to do the first one here, and you need to find these other coordinates yourself by multiplying the same way. We're going to multiply by 3/5. So 5 goes into 5 one time. Bring that 1 around. 1 times 3. And that ends up being 3. So our first coordinate here is 3. So you follow the same process, in and around. Multiply the two coordinates down below. Now ask yourself this, is this less than 1? It is, which means we're shrinking. If it's bigger than 1, we're making larger. In 23, it says, in the coordinate plane, A is at negative 2, 1. So here's A, and it's at negative 2, 1. So A is at negative 2, 1, and we move it to 0.33. So we're moving that over to 3,3. That's sub A. So let's write this out. We're at A is at negative 2, 1, and then we have sub A, which is 3, 3. It says under the same translation, so whatever the motion is, we're going to translate points B. B is at 0, 3. And then C is at negative 4, 4. So there's C. You see we have a triangle here, ABC, so we're translating it. So we want to see translate means to slide. We add to the left, add to the right. To slide. Add to the left, add to the right. Right here. Translation is to slide. Add to the left, add to the right. So we want to ask ourselves, what was the translation that we added to the left and added to the right? So we take a look. From here, negative 2 to 3, we needed to add 5. So we're going to, for the new coordinates, we add 5 to the x coordinates. And then from 1 to 3, we added 2. So using that rule, find these new 2 coordinates, and you should see that we shifted this triangle 5 units to the right and 2 units up. So get those other 2 coordinates, close it up, make a triangle. Find the measure of each triangle using special right triangle properties. Keep answers in simplified radical form. Well, special right triangles mean we're using the 30, 60, 90 and 45, 45, 90 charts. You want to write those out. I'm going to wait just a moment. Make sure you get those written out. Okay, so looking here on the left, we see everything goes back to the short leg. Do you see that? So we always start with the short leg. Identify the short leg. So the short leg is here. It's A. So to go from the short leg to the hypo, we draw a line and we write times by 2. And then to the long leg, it's times by root 3. It says find the measure of each side. So we want both sides, even though there's only one variable. So here on the left, we have something times, we have to find A before we go to the left. So this reads like this. Something times root 3 is 2. Something times root 3 is 2. Now there's a couple ways you can do this. One is algebraically, and one is what I call logically. Let me show you how to solve it algebraically. So here we have A times root 3 equals 2. To solve it algebraically, you're going to divide by root 3. Get A equals 2 over root 3, except you can't have radicals down below, so top and bottom by root 3. So A equals 2 root 3 over 3, and you're done. Another way is just to logically work yourself through this. So you start with this. We know we need at least a root 3 to get rid of that radical. But root 3 times root 3 is 1. I mean, it's root 3 times root 3 would give us 3. So you ask yourself, what do you divide by in order to get 1? And we divide by 3. So now we have a 1. Now ask yourself, what times 1 is 2? And the answer is 2. So there is the logic method and the algebraic method. So what goes in here is 2 root 3 over 3. And when I go this way, I simply times by 2. So 2 root 3 over 3 times by 2. Only the outies talk to each other, so it's 4 root 3 over 3. Okay, we're done on the left. On the right, we label. We have legs, and a hypo. This one's easy. The legs are equal, so if that's 5, this is 5. To go from the leg to the hypo, we times by root 2. So this answer here is simply 5 times root 2. You have the one down below to work on. Okay, students, I can't emphasize enough the need to have these 2 pages memorized. It is absolutely vital. So take the time to fill that out several times.